All right, so we're going to be solving, so chapter 4 now is pretty much chapter 3. It's the exact same stuff. It's sine law, cosine law, but we're going to be solving with obtuse triangles, okay? What's that? This is chapter 4, okay? Obtuse triangles. So it's the same thing. Sine law and cosine law are the exact same stuff as before. So you still have a triangle. Okay. And your sine law and cosine law are still the exact same. Okay, so your formulas haven't changed, which is awesome, right? Great. We're not learning a whole lot of new stuff here. It's a smooth, seamless transition into the next chapter of our mathematical lives. I used to write for a soap opera. Yeah, maybe. He is a hero. But obtuse triangles, all that changes is one of these angles, either A, B, big A, big B, or big C, will be obtuse. Do you guys remember what obtuse happens to mean? There's like 3 types of angles. There's acute, there's a right angle, and obtuse. Opposite. It's greater than 90. Okay? So one of the angles will be obtuse. Now this is where it gets interesting because things can kind of get a little interesting when you start taking sine of angles bigger than 90 degrees. Okay? You can take sine of any angle you want, but sine tends to have repeating numbers in it. Same with cosine. Okay? So what we're going to do today is we're just going to look at properties of sine and cosine. Because when we're using them in our laws, right, here, you just have to be aware of certain things. Okay? So like let's, for example, just say we wanted to take the value of sine, let's go 80. All right? So if you were to punch that into your calculator, .98. Give me a couple more decimals. 0.48. Perfect. So we know that 80, if we had a drawing like this, this is 90 degrees, okay? We know that 80 degrees, that's all color. right here, right? That's 10 degrees less than 90, right? Now let's go the opposite direction, and let's go 10 degrees greater than 90. So that's going to make my angle what? 100, right? Let's look at 10 degrees more than 90. Okay, so now let's look at sine of 100. Right, it's the exact same thing. Okay. And this kind of works for anything. Let's say we took the sine of 30 degrees. What'd you get, Bree? 0.5? All right. Okay, now so that's 50 degrees less or short of 90, right? Or sorry, 60 degrees less of 90, right? So let's look at 60 degrees more of 90, 150. Same thing, right? Okay, so there's a pattern here that kind of repeats. All right, if you look here on the pattern, if you take these two numbers and add them up, what do you get? 180. If you look at these two numbers and add them up, 180. Okay, so sine for any angle between 90 to 100 kind of works like this. You take the sine of any angle. Make sure your angle, though, is less than or equal to 90 degrees, okay? That's going to equal sine 180 minus that angle. Okay, so if I wanted to take sine 62, I know that equals sine 180 minus 62. Okay. Sine 62 actually equals sine working on my mental math. I told the kids in calculus that they can't use calculators. I got to brush up on my math. To do sine of a value? Oh yeah, totally. There's like 4 numbers that you learn sine and cosine of. Well, the numbers repeat, but it's just a pattern. 30, 60, 45. You got what? Yeah, that's not right. You took sine of this. So if you go, I get 8829. That's 62. Oh no, just if you're just go 180 minus 62, you go sine of that. So you just got to go sine 62. You're just finding, yeah, don't overthink it. So you know that sine 62 would just be 8829. And sine 118 would be the exact same thing. Okay? Now, why does this matter? Not only is it a neat little pattern. Oh, what did I do there? Take out the sine. This doesn't matter. They're just equal to each other. Okay, so now why does this matter? What it matters is if you're solving for an angle, like if you put sine -1, 0.8829 into your calculator, got it done. Just leave it on the microscope. I'll put the microscope away, okay? Thanks, Kim. If you punch this into your calculator right now, it's going to say that if you take sine -1 of 0.8829, it's going to equal 62 degrees. Okay? But it could also be 118. But your calculator only gives you the answer between 0 and 90. Okay? So only give answers it will never do it. It just won't. It won't. Okay? So you just have to be aware, if you're solving for a obtuse triangle, you need to know if it gives you an answer of, say, 62, you need to go 180 minus that number. All right? So if you're solving obtuse triangle, you'll need to subtract 180 degrees from your answer. And so it would just be 180 minus. Kind of make sense? Yeah? Sam? You'll just need to be aware of when it is a obtuse or when it is obtuse, okay? What we'll be working on for the next little bit. Always obtuse. Okay? And cosine works a little differently. Okay? For sine, it was, for sine, it's this. For cosine, if you were to do that, your answer is always going to be negative values. For if it's between, if your angle is between negative or 80 or 90, sorry, and 180. Okay, so what that means, like let's go with 30 degrees again. So we know, let's do cosine 30 degrees. And we'll compare that to, I'm going to change colors. And we'll compare that to the cosine of 180 minus 30 degrees. So we'll look at both of these and see what numbers we get. Because apparently I just told you the rule. So let's see if that's true. So cosine 30, someone tell me what that is.
0.8660.
0.8680?
Another 6.
60? Okay. Cool. Now let's cosine. So cosine 180 minus 30 would be cosine 150.
Again, negative.
Oh, the system works. It's going to be negative. Oh, not. Whoa. Get cocky. 8, 6, 6, 0. Okay. So what's nice about cosine when you're solving for obtuse triangles is that you don't have to like rely on it going. You don't have to go back and like if you get cosine for an angle, you don't have to go 180 minus that. You're just going to have a negative value here to put into cosine, and that's okay to do that. All right. So when we're solving these obtuse triangles, if you're solving for the angle, you're gonna get a negative value that you put into cosine, and then it'll just be bigger than 90 degrees. Okay. So this one is really easy. People tend not to worry about it at all because you don't really have to. The only tricky part with all this is knowing if you're solving for an obtuse triangle that this is going to happen. So if you're solving for an obtuse triangle angle and you get something smaller than 90, what do you do with it? If you solve for sine and you get sines 45 degrees, but you know it's actually an obtuse angle, what do you got to do to that angle? Right, you go 180 minus 45. Okay? So basically, this is the big one here. Whenever you're working with sine and you know it has to be obtuse, you just go the angle. You go 180 minus the angle. Okay? Any questions about that? This is kind of a weird little lesson. It just makes it easier down the road, okay? So your homework, your work for today, big lesson, guys. These driver's ed guys are going to have so much work. On page 163, what's that?
2 questions.
Not 2 questions. 4, and you have 45 minutes, or you have 35 minutes.
Grade 7.
Did you guys get a lot of homework from grade 7?